Okay, today I'll be revising the 3 sections of Chapter 7, Circular Motion, Newton's Law of Universal Gravitation, and Motion in Space. Now, first of all, circular motion. What is circular motion? It is the motion when an object moves, spins, or rotates around a fixed axis of rotation. Now, the physical quantities involved in this is tangential speed, Vt, which is the speed of an object in a circular path. When the tangential speed is constant, we call this motion UCM, or uniformal circular motion. And the more the radius, the more the Vt. And Vt always changes direction. Now, it is measured in meters per second, which is the unit. When the velocity is constant with no acceleration, this means it's not changing direction. Now, centripetal acceleration, AC. The acceleration directed towards the center of a circular path. Centripetal acceleration is due to the change of Vt direction. Now, acceleration has velocity, and velocity is a vector quantity. So, acceleration is a vector quantity. A vector quantity meaning that it has both magnitude and direction. Now, AC equals to Vt squared. The formula of centripetal acceleration is AC equals to Vt squared over R, the radius, and the unit is meters per second squared. Now, when a car is like it's rotating around a roundabout, the Vt is changing direction. And the car is changing direction. This means there is acceleration. Now, remember that acceleration is the rate of change of v, or due to the change in direction, or it could be both. Tangential acceleration. It's the acceleration due to the change in speed. Now, centripetal force. It is the net force that is directed towards the center of an object's circular path, or it is the force that keeps an object in a circular path. Now, Fc, the formula of Fc is m times AC, and remember that AC equals to Vt squared over R. So Fc equals to m times Vt squared over radius, or R, and the unit is newtons. And centripetal means center seeking. Now let's do some practices for centripetal acceleration. A rope attaches a tire to an overhanging tree limb. A girl swinging on the tire has a centripetal acceleration of 3.0 meters per second squared. If the length of the rope is 2.1 meters, what is the girl's tangential speed? Now, let's take out the givens. We have the centripetal acceleration, the AC, which is 3.0 meters per second squared. And we have the radius, which is 2.1 meters. Now, what is the Vt? Now, let's start solving. AC equals to Vt squared over R. AC, which is the 3, equals to Vt squared, which we don't know it, over the 2.1. Now, we're going to multiply this. So we're going to cross multiply. So, it's going to be Vt squared equals to 3 times 2.1. So, Vt squared equals to 6.3. Vt equals, we're gonna like square root the 6.3, which is gonna be 2.5 meters per second. Don't forget the unit. Now, another one. A dog sits 1.5 meters from the center of a merry-go-round. The merry-go-round is set in motion, and the dog's tangential speed is 1.5 meters per second. What is the dog's centripetal acceleration? So now the givens are the radius, which is 1.5 meters, and the tangential speed, the Vt, which is 1.5 meters per second. And we have to know the AC. Now, AC equals to Vt squared over R. We don't know the AC. Vt squared is 1.5 squared over 1.5. So it's going to be 2.25 over 1.5 will be 1.5 meters per second square, which is the AC. Now, centripetal force. Now let's do some practices for this. A 2.10 meters rope attaches a tire to an overhanging tree limb. A girl swinging on the tire has a tangential speed of 2.50 meters per second. If the magnitude of the centripetal force is 88 newtons, what is the girl's mass? So now let's take out the givens. Radius equals to 2.10 meters. and the VT is 2.5 meters per second, and the centripetal force, which is given, is 88 newtons. Now, Fc equals to m times AC. Now, remember that we said that the AC is VT squared over the R. Now, the Fc is given, which is 88, and we don't know the mass, we need to find it. Now, the 2.5 squared over the 2.1, so it's gonna be it's gonna be 2.97 divided both sides. Okay, so it's gonna be mass equals to 88 over 2.97. Now the mass will be 29.6 kilograms. Don't forget the unit. This is the mass. Now another question. A dog sits 1.5 meters from the center of a merry-go-round and revolves at a tangential speed of 1.8 meters per second. If the dog's mass is 18.5 kilogram, what is the magnitude of the centripetal force on the dog? Let's take out the givens, which is radius equals to 1.50 meters, and the velocity or the tangential speed is the 1.8 meters per second. The mass is 18.5 kilogram. Now the same thing, Fc equals to m times Vt squared over R, which this is the AC. We need to find the Fc. Fc equals to 18.5 times the Vt, which is 1.8 squared over the radius, which is 1.5. So it's going to be 39.96 newtons. Don't forget it. Now we finished from section 1. Now we will be going to section 2, the Newton's law of universal gravitation. Gravitational force is the force of attraction that pulls an object downward. Now from the textbook they have a different meaning, which says that the gravitational force is the mutual force of attraction between particles of matter. It could be either this or that. Now, orbiting objects in free fall. Now the gravitation, let's say that we have a cannonball on Earth, and it will reject the cannonball. The gravitational force between the cannonball and Earth is centripetal force. Now, when the VI is great enough for the ball, the curvature of Earth will cause it to fall without ever landing. So when the VI is really huge, like a huge amount. Now, gravitational force depends on mass and distance. Newton's law of universal gravitation, which is Fg equals to G constant. Now, what is G constant? It is universal constant of gravitation, and it equals to 6.673 times 10 to the power of negative 11 n times m squared per kilogram squared. So let's go back. Fg equals to G constant, which we know now what it is. M1, M2, which is mass 1, mass 2. Now this, they will give you the question, they will give you both the masses over the R squared, which is the radius. Now let's practice. Mars has a mass about 6.4 times 10 to the power of 23 kilogram, and its moon Phobos has a mass about 9.6 times 10 to the power of 15 kilogram. If the magnitude of the gravitational force between the two bodies is 4.6 times 10 to the power of 15 newtons, how far apart are Mars and Phobos? So we'll take out first of all the givens. Mass 1, which is 6.4 times 10 to the power of 23 kilograms. Mass 2, which is 9.6 times 10 to the power of 15 kilograms. And then we have finally the force, or the Fg, is 4.6 times 10 to the power 15 newtons. Now let's first apply the formula. Fg equals to G constant, mass 1, mass 2 over R2. And don't forget that the unit is newtons. Now we have the Fg, which is 4.6 times 10 to the power 15, G constant, which is 6.673 times 10 to the power of negative 11. The M1, which is 6.4 times 10 to the power of 23, then 9.6 times 10 to the power of 15 over the R squared. And here they're saying how far apart, so we need to find the radius. Now let's do this by the calculator. Let's first multiply this by this, and then we multiply it by this. Or you could just multiply this, and then divide it by the R squared. So it's gonna be 6.4, or let's start with 6.673. Okay, so 6.673 times 10 to the power of negative 11 times 6.4 times 10 to the power of 23 and then times the 9.6 times 10 to the power of 15. So it's gonna be 4.09 times 10 to the power of 29 over R squared over 1. So let's go here. 4.6 times 10 to the power of 15 R squared equals to 4.09 times 10 to the power of 29. Now we're going to divide this by 4.6 times 10 to the power of 15. Now R squared equals 2. Now let's divide this, the 4.09 times 10 to the power of 29 divided by 4.6 times 10 to the power of 15. It's going to be 8.91 times 10 to the power of 43. Now let's square it. 8.9 times 10 to the power of 8.91 times 10 to the power of 43 to the power of 43. So the answer would be, the radius would be 9.43 times 10 to the power of 21 meters. That's the answer. Now, gravitational force acts between all masses. Now, the gravitational force exerted on the sun is greater than the gravitational force exerted on Earth. So, the sun has more mass than Earth does. So, that's why the sun pulls Earth towards it. Fg, which is the gravitational force, and gravity equals to mass. The more the mass, the more the gravitational force. The less the mass, the less the gravitational force. Now, as you can see here, the sun has more Fg and more mass than the Earth. Now, also, the more the distance, the less the Fg. The less the distance, the more the Fg. Now, gravitational force equals to free fall acceleration. A equals to force, the force over m, and then G equals to Fg over m, and then G equals to 9.8 meters per second on Earth's surface. Now, let's see some questions reviewing main ideas. First of all, explain how the force due to the gravity keeps a satellite in orbit. So let's say this is the planet or planet Earth, and then we have the satellite. Okay, horrible drawing, I know. A satellite moves tangentially around a planet and would continue to move in a straight line if there was no Fg. The combination of acceleration due to gravity and the tangential speed causes the satellite to follow a path that is parallel to the curvature of the planet. Now, another question. Is there gravitational force between two students sitting in a classroom? If so, explain why you don't observe any effects of this force. Now, yes, the magnitude force. Now, why? The magnitude force the magnitude of the force is extremely small. That's because the mass of the students is small compared to Earth's mass. Another question. Why does a passenger in a car tend to stick to the window while turning around the roundabout? Now the answer is, it is because the passenger is trying to keep his or her inertia, which was moving in a straight line. And inertia means the tendency of an object to remain at its state. Now we finished from this section. Now we'll go to the last section, finally, to motion in space. Motion in space 7.3. Now, motion in space. Now, Kepler. Now, first of all, we have this scientist called Claudius Ptolemy. He stated that Earth is the center of the universe, and planets orbit it in small circles called epicycles. Now, another scientist, Nicholas Copernicus, stated that Earth and other planets orbit the sun in perfect circles. Both statements are wrong. Kepler corrected them by stating his three laws. First of all, a planet orbits the sun in an elliptical path, and the sun is at one of the focal points. Okay? Now, the second law states that an imaginary line drawn from the sun to any planet sweeps out at equal areas and equal time intervals. So A1 equals to A2, delta t equals to the second t, but at different speeds. Okay? Now, the third law stated that the time squared is proportional to the radius of orbitation cubed. So t squared is proportional to r cubed. Kepler's third law explains orbital period. Now, t squared equals to 4 pi, which is 3.14, divided by the gm, g which is constant, and m which is the mass, times the r cubed, which is the radius. And the unit is s, which is seconds. Now, there's another formula which is for the speed. Now, like the orbital speed, okay, which is vt squared. Vt squared equals to g constant, m over r, which is mass over radius, and the unit is meters per second. Now, let's try solving a question from this. Let's try to solve a practice. Now, the color enhanced image of Venus shown here was compiled from data taken by Magellan, the first planetary spacecraft to be launched from a space shuttle. Now, during the spacecraft's fifth orbit around Venus, Magellan traveled at a mean altitude of 361 kilometers. If the orbit had been circular, what would Magellan's period and speed have been? Now, the givens are the radius was 361, which is converted from kilometers to meters. It's going to be 3.6 times 10 to the power of 5 meters. Now, the second radius, which is 6.05 times 10 to the power of 6 meters. Now, we're going to add this with this. These two values is going to be 6.41 times 10 to the power of 6 meters. And the mass is 4.87 times 10 to the power of 24. Now, we're going to have to find the orbital speed and the orbital period. Now we're gonna have now we'll just start with the orbital period. Okay, so let's start with the t squared formula, which is 4 pi squared over gm and then times the r cubed. Now, we need to find the t squared. Now we're going to do this. Simply, we're going to do 3.14 squared over the g constant, which is 6.673 times 10 to the power of negative 11, times the mass, which is 4.87 times 10 to the power of 24, times the r, which is, we said that it's 6.41 times 10 to the power of 6 cubed. Now, we're going to have to find all of this by the calculator. Let's just first multiply this by this, and then divide it by this, and then multiply it by this. So, first of all, I'm going to do 4 times 3.14 squared, and then we're going to have 6.673 times 10 to the power of negative 11, and then multiplied by 4.87 times 10 to the power 24. Now it's gonna be, let's just get the, okay, multiply by 6.41 times 10 to the power of 6, and then cubed. Now this is what I got: 319.6268.7.59. Now I have to square root this, of course. Don't forget, because there's a squared. Now it's gonna be 319. Put the values. 687.59. So the answer would be T equals to 5653.55 seconds. Don't forget that the unit is seconds. And we could apply it also for the orbital speed, which is the Vt squared equals to G constant m, which is the mass over the radius, r. Now weight and weightless. Now normal force in an elevator. Now first of all, the first situation, the weight is 600 newtons and the acceleration is equals to 0, Fn equals to Fg. Now the second situation, the A is decreasing, the weight is half the one before, which is going to be 300, and the Fg is greater than the Fn. Now the third situation, the A equals to G, which is 9.8, the weight, there's no weight, the weight is 0, the Fn is 0, there is no Fn, and the Fg is it's like still its value. And now the boy and the elevator are in free fall. Both the boy and the elevator are free fall. The scale will rate 0, but the boy's weight is still the same. So this means that, and when there's no Fn, this means it is weightless. Okay, it is weightless. So this is the end of the section and the end of the revision of this. And I hope you enjoyed and understand, hopefully, and thank you.